All right, trust you did well on quiz 39. Turn your textbooks, if you would, to page 236. And I want to go a little deeper now on parabolas. Obviously, a concept that wasn't quizzed, but something I want to go over with you anyway. That is coming up with the equation of a parabola given information. We did with this with the circle as well, right? I told you, okay, maybe the endpoints of a diameter are these. What's the equation of the circle? Or perhaps I said, well, this circle's concentric to that one, and it passes through this point. What's the equation? Or maybe I said, this circle is tangent to this line, and it is concentric with this other one. And we're going to find the equation of the circle. And that was key in understanding the circles, I felt, because it allowed you to figure out that really there's only two things that matter for the equation: center and radius. Well, in the case of the parabola, in the form, there's only two things that matter. Think about it. If we've got x minus x1 squared equals 4p y minus y1, the two things that matter are the x1, y1 class, which is the Vertex. Sorry, out of habit there. Got an empty room at the moment for this recording. And then, but you feel free to answer while you're watching the video. And then the p-value as well, which is our focal length. If I know these two things, I know the equation of my parabola. That's what I've got to find. So look at the example problem here on page 236. It says, find the equation of the parabola with the vertex 2, 3, and the focus 2, 1. Well, if I know the vertex, I already know these two numbers. I already know, well, but remember, it could be y minus y1 squared equals 4px minus x1. I know the x1 regardless is a 2. I know the y1 regardless is a 3. But what's the p? And which way do I set it up? One of the things the book suggests, and I suggest as well, is draw a quickie sketch. Just a real quick sketch. If the vertex is at 2, 3, there's the vertex. If the focus is at 2, 1, then there's the focus. And remember, the parabola wraps around the focus. So that means it's a down parabola, which means which axis is the axis of symmetry? The y-axis. Well, that means we're going with this form that has the y at the back end. So I know it's going to be x minus 2 squared equals something y minus 3. But what is the p? What is the focal length? Well, from this vertex to this focus is down 1, down 2. Down 2 means negative 2. The focal length must be negative 2, which means negative 8 is the number that goes right there. And then if we wanted to, as we did with the circle, expand that out to the conic form. Well, that's x squared minus 4x plus 4 equals negative 8y plus 24. Or in the conic form, x squared minus 4x plus 8y minus 20 equals 0. And I go one step further than the example problem. They left it in the parabolic form. I like to take things back out to the conic form. But there we go. As soon as you figure out vertex, which they gave to us, that helped, and the focal length, okay, just took figuring out which axis was the axis of symmetry and how far was the focal length, of course accounting for negative and positive, we were able to come up with the equation. That's the example 3 problem. Turn over now to page 238, and let's look at a few of these problems now. Problem number 11, look at part A. Problem 11, part A. Note the information that we're given. Very similar to the problem we just did, right? We know the vertex already, 5, 0, and we know the focal point, 5, 3. Again, my recommendation would be start with a sketch. So on your paper, go ahead and draw a quickie sketch. And which direction does the parabola go? Up, down, left, or right? Certainly, it's going up. If it's going up, the axis of symmetry is the y-axis. And the focal length is positive 3. So at your seats, write the formula. Pause the video for a moment while you're, not the formula, but the equation of the parabola. Pause the video while you do it. All right, let's see how we did. Hopefully you said, well, since the y-axis is axis of symmetry, I'm going to start with the x minus 5 squared equals 4p times y minus 0 squared, or not y minus 0 squared, but just y minus 0, or y. Hopefully then you also said, well, if I expand this out, I get an x squared plus 10x minus 10x plus 25 is equal to 12y. But when we bring that over as a negative 12y, I get this. And there's the equation of my parabola with a vertex at 5, 0 and a focal point at 5, 3. I want you to try letter C. I want you to try letter C. Pause the video while you work the entire thing, and then I'll go over it. All right, let's take a look at letter C and see how you did. Very similar to the example, very similar to the last one. We know the vertex is 2, negative 1. I know the focus is negative 1, negative 1. So I trust what you did was you drew a quick sketch. You went to 2, negative 1 for your vertex, and you went to negative 1, negative 1 for your focus. You realized that because the parabola is going to open this way, the axis of symmetry is the x prime axis, which means we're going to do y minus something squared equals something x minus something else. And since the vertex is 2, negative 1, it's x minus 2 and y minus negative 1, or y plus 1. You hopefully then also realize that from here we go 1, 2, 3 backward for the focal length. So p is a negative 3, so we get a negative 12, 4p in this spot. And then hopefully you squared, distributed, brought the 12x over as a positive 12x, brought the 24 over as a negative 24, which actually gives you negative 23 because of the positive 1, all equal to 0. If you had this, well, you can't comment on the video, email me or let me know, Jamie and Quentin, let me know on Monday if you were able to get letter C on your own. Again, this isn't going to be tested or quizzed, but it deepens our understanding of parabolas. I want to look now at letter D. This one's very different. Letter D is very different from the last two, mainly because they don't give you the vertex. They also, they do give you the vertex. They don't give you the focus, but they give you something just about as good. Look with me here. We know the directrix, dd prime, is x equals negative 2. Now, what does that look like if we graph that line? X equals negative 2. Remember, that's going to be a line parallel to the y-axis. This is my directrix. Now remember, the directrix is always perpendicular to the axis of symmetry. So which axis is the axis of symmetry? The x prime axis. Somewhere along here is an x prime axis. And since the vertex is at negative 1, 3, it must be an x prime axis right here. So we know the form here is going to be y minus something squared equals something x minus something. The x has to be the non-squared variable. And since the vertex is negative 1, 3, I know it's going to be an x minus negative 1, or x plus 1, and a y minus 3. The only question is the focal length. Well, remember, if the parabola comes through here, this distance from the vertex to the directrix is the opposite of the focal length. Well, the directrix goes through at negative 2. The vertex is back at negative 1, so this distance is only backward 1. What's the focus? Focal length. Forward 1, correct? So if the focus is here, forward 1, p is a positive 1, the number here is a 4. And again, we square, multiply and double, and temporarily get a plus 9. This gives us a plus 4. The 4x is going to move over as a negative. We're going to bring the 4 over as a negative to get a plus 5 equals 0. And there is the equation for letter D. Again, instead of getting focus and vertex and focus, we had vertex and directrix. But the directrix gives us the focal length anyway. Letter B is perhaps the most unique. That's the one I thought we were going to do next. I can't read my own notes. Letter B, this time they don't give us the focus, or the vertex rather. They give us the focus and one end of the lattice rectum. One end of the lattice rectum. Very interesting. Well, again, let's draw a sketch. We know the focus is at 3, 2. That's the focus. One end of the lattice rectum is at 11, 2. Now this could be L or it could be R. If the lattice rectum, if one end is here, the other end's got to be out here somewhere, correct? This is either R or L, depending on whether the parabola goes like that or whether the parabola goes like that. Does that make sense? Either way, because the lattice rectum runs horizontal, the axis of symmetry must be vertical, must be the y-axis. So we know we're going to have x minus something squared equals something y minus something. So far, so good? How long from 3,2 to 11,2, how long is this half of the lattice rectum? Yeah, it's 8. Half the lattice rectum is 8. But remember, that's absolute value of 2p. So therefore, p must be what? What's the focal length if half the lattice rectum is an 8? Yeah, the focal length must be either 4 or it could be -4, couldn't it? By the way, this is also another 8 for a total length of 16. But either the focal length from vertex to focus is 4 or vertex to focus is -4. Focal length could be either one. But either way, if we have 4p right here, 4 times positive -4 is going to give me either a positive or a -16. Let's, instead of writing positive negative, treat it like 2 separate equations. Let's treat it like a 16 and a -16, because if it's a 4, the vertex is down here. If the focal length is -4, the vertex is up here. So the vertex is going to be different regardless. If the vertex is down, the parabola goes up. What would be down 4 units? From 3, 2. Down 1 is 3, 1. Down 2 is 3, 0. 3, -1. 3, -2. That could be my vertex if we have a positive focal length. But 3, 2 going up 4, so that would become down 4 from the vertex. We have to go up 4 to get to it. All right, that's going to be 3, 3, 3, 4, 3, 5, 3, 6. And there's 2 different equations. For sake of time, I won't actually put these into the conic form. The book is leaving it in parabolic form anyway. But these would be my 2 equations that could give me a focal point at 3, 2 and one end of the lattice rectum at 11, 2. 2 possibilities in this case. Again, circles I tested and quizzed you because circles were so easy if I hadn't. If all we did was graph, that's just too easy. Parabolas, the main thing is the graphing, but I did want to talk through this analysis with you and show you how, like circles, we can find equations of parabolas based on given information. Your homework for this evening is going to be to read over pages 238 to 244. We're going to preview in your reading ellipses. Like the reading on parabolas, you may not understand everything you read, okay? Do the reading anyway, and then as I talk through it, having seen it once before, my talk will make more sense to you, I think. But read through pages 238 to 244 as you preview ellipses. In addition, I have one equation that I want you to graph. I want to go back and review circles. Make sure we don't forget that. As we work our way through conics, it's important not to forget the old conics. Okay, we just did parabolas today. I don't think we're going to forget parabolas. At least not yet. We'll review those more later. Want to review circles, and then we're going into ellipses in our next lesson. And we'll see you then.